All right, and what we're looking at today is we're going to be looking at more of these equations, solving solving radical equations with radicals in them. But one of the key things that we're going to add today, and is going to be different today, is that we can have extraneous solutions. So we're going to have values of x that when we solve, we will get, but they will not work in the original problem. One of the big things that we have to focus or kind of pay attention to is that we cannot have a negative number as inside the radical. Now, when I say that, I don't mean that I can't plug in -2 for x. That's fine. Because if I plug -2 in here for x, I would have -2 plus 6. And well, -2 plus 6 is 4. When I take the square root of 4. Yeah, this is 2. So that would work. That's fine. But what I cannot have is, say, -8. Because if we plug this in here, we would have -8 plus 6. Well, what is -8 plus 6? Can I take the square root of -2? No, without imaginary numbers. We cannot have a real number come out of the square root of -2. So when I say we can't have negatives inside the radical, we can't have answers that when we plug it back in, we get a negative in that root. We have, like here, the square root of -2. Or when we plug it back in, it will simplify down to having a negative. It doesn't work. And we'll be solving these here. Now, our overall steps that we did yesterday and that we'll do today are going to be the same. So when we look at this here, x is equal to the square root of x plus 6. So we do only have one radical in this equation. And is it by itself? Yeah. Yes, okay. So we want to simplify that radical by putting both sides to the what power? The second power. We want to square both sides. And when we square both sides, well, x squared is going to be, well, x squared. And the square root of x plus 6 squared, well, the square root to square would simplify, leaving us with x plus 6. Any questions on this here so far? Now, unlike yesterday, because yesterday everything we dealt with and solved for, the biggest exponent was 1. We didn't have any quadratics. Here we have a quadratic. We do have an x squared term, which means we have to get everything on the same side. So we'll have to subtract x from both sides, which will give us x squared minus x is equal to 6. And then we'll have to subtract 6 from both sides. I'll scroll back down, which would give us x squared minus x minus 6 is equal to 0. Because we had a squared term, a degree greater than 1 for one of our exponents, or had one of our exponents greater than 1 on the variable, we had to move everything to the same side. Since we have a quadratic, we need everything on the same side of the equal sign. So we have it equal to 0, and really we're just solving it, this quadratic. Any questions on how we got to this quadratic here? Now at this point here, we can go in one of two directions to solve it. We can either factor it, or we can use the quadratic formula. What do we want to do? We can factor it. What are our signs going to be? Positive, negative, yes, because the third term is a negative, so the signs would be opposite. Factors of the first term would be x and x. Factors of the third term. Yes, positive 2 and negative 3. And if we check this here, we could see is x times negative 3 would be negative 3x, and 2 times x would be plus 2x, which would give us a negative x, which is what we wanted. Questions on this here?
Can you show me the quadratic formula?
Yes. So we get this here. Now from here, because we have two things multiplied together that equals 0, one of them has to be 0. So it means for us here that either x plus 2 is equal to 0 or x minus 3 is equal to 0. And at this point here, we can solve each one of these here. I can solve this one here by subtracting 2 from both sides, which would tell me that x is equal to negative 2. And here we can add 3 to both sides, which would tell me x is equal to 3. Now, we're not quite done. We do need to check this. Whenever we have variables outside of the radical, so let's look back at the top. I'm going to scroll back down here in a minute. We have x equals the square root of x plus 6. We need to be careful. Whenever we have a variable outside and we square it, we need to be careful. Because our starting equation, x is equal to the square root of x plus 6. So what we need to do is we need to check them to make sure they work. I'm going to start with negative 2. Because if I plug it in for x, I'd have negative 2 is equal to the square root of negative 2 plus 6. Well, the negative 2 on the left is not going to change because there's nothing with it. Now, the square root of negative 2 plus 6, well, negative 2 plus 6 is 4. What's the square root of 4? Is negative 2 equal to 2? No. Which tells me this is not a solution. It doesn't work. Because when we plug it back in, both sides are not the same. Now we can try the same thing with 3. Plug it in for x. Well, the square root of 3 plus 6, well, 3 plus 6 is 9, and the square root of 9 is, so that does work. Now, if you notice in both of these cases, when we checked it, the number that we got were the same. The signs were different. Like when we plugged in negative 2, well, we got negative 2 is equal to 2. They're still both 2, the signs changed. And that's dealing with the fact that we squared both sides. It's changing that sign. So we have to take that back into account. Questions on this here? Has this made these any harder than what they were yesterday? They added a few more steps and a few things we have to pay attention to. But we're still doing the same type operations. Okay, let's look at this one here. X is equal to the square root of 20 minus x. Is the radical by itself? Yes, there's nothing else with the radical. The square root is by itself. Nothing being added to that radical or there's nothing being multiplied by the radical. So what can we do? We can square both sides. Well, x squared is just going to be x squared. Now the square root and square over here will simplify out, leaving us with 20 minus x. Well, again, we have a quadratic. In most of these here, when we have that variable outside, we'll have a higher degree polynomial. And since we have this higher degree polynomial, we've got to move everything to the same side. And here, I'm going to have a tendency to move everything towards the x squared since it is positive. I like to keep the x squared positive, the biggest term positive. So we can subtract 20 first, which would give us x squared minus 20 equals negative x. Then what can we do? We can add the x to both sides. X squared plus x minus 20 is equal to 0. So again, just like the one before, at this point here, we can either use the quadratic formula or we can factor it. What do we want to do? Okay. Let's use the quadratic formula for this here. Now the quadratic formula again is x is equal to negative b. So negative b, well, our b value is would be the number in front of x, 1, so you'd have negative 1, plus or minus the square root of b squared, 4, a is, and c is, and it would be negative, because we take the negative with it, all over 2 times a, well, 2 times 1, and again, I'll write it up here, just so we have it. And we have this here. We plugged in for a, b, and c, and we get this here. Now, we can simplify what's inside the square root first. And when we do that, well, we'd have x is equal to negative 1 plus or minus over 2. Now, at this point here, we could plug everything that's inside this radical into a calculator. And if we do that, we would get, because 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 20, well, the negative and negative would give us a positive. 4 times 20, and 80 plus 1 is 81. Now, can I take the square root of 81? And it is? Well, hey, we like that. And the reason we like that is, well, can I do negative 1 plus 9? We can do also negative 1 minus 9, yes? So that means I can split this up into negative 1 plus 9 over 2 and negative 1 minus 9 over 2. That means we can actually go and find the values of x, since we can add and subtract these. Now, negative 1 plus 9 is, and 8 divided by 2 is, so one of our values of x is 4. Now, negative 1 minus 9 would be negative divided by 2. And we get this here. So any questions on how we found 4 and negative 5? Which one do we think will not work? Yes. Because when we look back at the original statement, I'm going to write in different colors. Our original statement was x is equal to the square root of 20 minus x. What do we know about radicals? What numbers cannot come out of a radical?
Negative.
They can't be negative. Is there anything affecting that x outside? No. So there's nothing that's going to make this x become positive if it was negative. So when we do negative 5, it'll be negative 5 is equal to the square root of 20 minus negative 5. That's not going to work because a radical cannot equal a negative. Will this always be the case? Well, no. We can have some set up some equations where the negative number will work. It will give us a true answer. Where a negative x can be a negative value? Well, yes. So you'll still need to check it. Some of this here, even with 4, can we plug the square root of 20 minus 4 into the calculator? I mean, it's all numbers, isn't it? Yeah, we can plug that in. So when we check it, we don't have to write it out by hand. Because 20 minus 4 is what? Square root of 16 is? So you could type that in. You could type in the square root of 20 minus 6, or 20 minus 4, and it'll tell you that it's 4. So on a lot of these here, we can check it with the calculator. We don't have to write it out by hand. Questions on these here? All right, we're going to move on to another type. Solve 13 plus the square root of 5n equals 3 for the value of n. Identify extraneous solutions. So looking at this here, is the radical by itself?
No.
What's with it? 13. So the first thing we need to do is what? Get the radical by its, yes? Okay, so what do? Subtract 13 from both sides. Which gives us the square root of 5n is equal to what? These become 0. 3 minus 13 is? Okay. What do we do next? We square them because the radical is by itself, yes? So we can square both sides. After us here, this radical and the square would cancel, leaving us with 5n is equal to negative 10 squared would be 100. Divide by 5. And that'll tell us n is equal to 20. Now they keep saying all this about extraneous solutions, so let's just check it to make sure. So it'd be 13 plus the square root of 5 times 20 equals 3, yes? Well, 5 times 20 is 100. The square root of 100 is? So that means this doesn't work, correct? Okay. I want to back up a step. What did we say a square root can never equal? It can't be a negative, right? Because we cannot take the square root of a number and get a negative. because it just doesn't work that way. We can't have a number times itself be negative without it being imaginary, correct? So is there any way that the square root of 5n can equal negative 10? Well, no, because it can't equal a negative number. Well, that doesn't work. This is a these here are the ones I will shy away from on a test. Okay? And the reason I shy away from on a test is not so much, okay, you did it right. No, I have a feeling most likely when you get to this point, your first thought is not going to be, hey, okay, it's a no solution. It's more likely, hey, I did something wrong. I did a step wrong. So I don't like putting those on a test. But they can be on the homework or the review sheet. Okay. Let's look at this one here. The square root of 3m plus 10 equals 1 is the radical by itself. We got a minus 10 from both sides. Those would cancel, leaving us with the square root of 3m equals so is the radical by itself. Is there something wrong with this statement? Huh? The 9 is negative, yes? Can a radical equal a negative number? So we could square it and go through the process, but would we get a real solution? No. Because this does not work. This is a but before you jump to no solution, make sure the radical is by itself. Because if this had been negative square root of 3n equals negative 9, then we would have a solution because, again, we need the radical to be by itself, and we would have divided by or multiplied by the square root of negative 1, which would have made the 9 positive. So once you get the radical by itself, there's nothing else with it, and it equals a negative number, there's going to be no solution because we can't have it be negative. Questions on this here? All right, let's look at this here. We will have quadratics. Okay. Now, when we do any of these here, we're still going to follow the same main steps. One, is the radical by itself? It is. The square root of 7p plus 15 is by itself. Since it's by itself, is it equal to a negative number? Well, no, it's equal to p plus 1. Could it be negative? Well, yes, but it can also still be positive. Like with the previous one where we had it equal negative 9, well, that's all it can equal, so it doesn't work. So that means we can move on to step 2. We're going to put both sides to the second power. We're going to square them. Now, on the right-hand side, we have p plus 1 squared. That is not going to be p squared plus 1. Because p plus 1 squared is really saying that I have p plus 1 times what? P plus 1. It's being multiplied by itself. So we're going to have to distribute that. Now, on the left-hand side, we have the square root of 7p plus 15 squared. Radical is by itself. So the radical and the square will cancel out, leaving us with 7p plus 15. Any questions on this here so far? Okay. Well, if we want to solve this, we need to distribute the p plus 1 times p plus 1. We need to simplify that. We start off by multiplying through by p. Well, p times p is p squared. P times 1 is going to be plus p. 1 times p is going to be plus p. And 1 times 1 is going to be 1. Any questions on how we multiplied this out? All right, let's combine like terms. Well, p plus p is the only like terms we have, would be plus 2p plus 1 is equal to 7p plus 15. Okay, we've simplified everything on both sides. It's as simplified as it gets. And because we have a quadratic, we need everything on the same side. So we need to move everything over. So before we start moving things from left or right to left, any questions on how we got to this point? Okay. So the first thing we can do is subtract 7p from both sides. Yes, we'd have p squared minus 5p plus 1 is equal to 15. Definitely got ahead of myself. If we wouldn't minus 14, we would. And if we minus 15 from both sides, then it gives me the 14. Are we good how we got to this point here? Yes? Do we want to factor it or use the quadratic formula? Either works. Because since the 14 is negative, we know the signs are going to be opposite. Now, since p squared is by itself, really we're going to be subtracting the factors of 14. So what factors of 14 can we subtract to get 5? 2 and 7. 7 minus 2 is 5, or really negative 7 plus 2 is negative 5. So this does work. It will factor. Our signs, as we said, are going to be opposite. What are the factors of the first term? And p. No. Factors of 14 are going to be, yes, and 7 being negative. So it does factor. If you feel more comfortable with using the quadratic formula, use it. It will give you the same answers. Because both of these multiply together to equal 0, one of them has to be 0. So here we can subtract 2 from both sides and get that p is equal to negative 2. And here we can add 7 to both sides and get that p is equal to 7. And it's always good, especially on these here, because we got a variable outside of the radical to check to make sure which one works. Is what we came up with. So we can start with -2. And we can plug -2 in for p. Well, we have -2 plus 1 is equal to the square root of 7 times -2 plus 15. Well, -2 plus 1 is -1. Well, I can stop there because I know that radical cannot equal a negative. But if we went on and did this here, 7 times -2 would be -14 plus 15. Well, -14 plus 15 would give us a +1, and the square root of -1, or +1 is 1, but they don't equal. We can't have a -1 equal -1, so it doesn't work. Seven plus 1 is equal to the square root of 7 times 7 plus 15. Well, 7 plus 1 is 8. Well, 7 times 7 is 49. 49 plus 15 is 64. And the square root of 64 would be 8. Okay. So that works. So that means for this here, the value of p, that is our solution, is 7. -2 would be an extraneous solution. It does not work. Questions on this here? Let's see here. I'm going to do one more today. Do we want to do this one here? 23? Because either 23 or 22. We can either do this one here or this one here. Want to do this? Huh? 23. Okay. Now, when we look at any of these here, before we start squaring or doing anything else, we need the radical to what? Be alone, be by itself. Is there anything with the radical? The 4. So how can I change that? We can -4 from both sides. If we do that, we will have the square root of -3m plus 10 is equal to m minus 4. All right. Is the radical by itself? Since it's by itself, we can put both sides of the equation to the second power. We can square both sides. And the reason we do this is because, well, the square root and square on the left-hand side will simplify because, well, we only have that one radical. So it will simplify. Which will give us -3m plus 10 is equal to. Over here, we're multiplying m minus 4 by itself. A little more room. And to simplify this here, we will distribute. M times m will give us m squared. M times -4 would be -4m. Now, negative 4 times m would be negative 4m. And lastly, negative 4 times negative 4 would be positive 16. I have a feeling some of you already went on and combined like terms. Because our negative 4m minus 4m will be negative 8m plus 16. Any questions on this thus far? Any questions on what we've done here? Well, now we need to get everything on the same side. So we can add 3m to both sides. It tells us that 10 is equal to m squared minus 5m plus 16. And then we would minus 10 from both sides. Okay, so telling us 0 is equal to m squared minus 5m plus 6. Now this here is still factorable, so we can factor this here. So what would our signs be? They would both be negative because the third term is positive, so we know the signs are the same and they match the sign of the middle term, which would be negative and negative. Factors of the first term would be m and m. 2 and 3. Yes. So we can split these apart because any two things multiplied together equals 0 tells me that one of them has to be 0. Now for our first one over here, we can add 2 to both sides, which tells me m is equal to 2. That looks promising. And over here, we can add 3 to both sides, which tells me m is equal to 3. Looks even more promising, yes? But since the theme of the day has been pretty much extraneous solutions, right? Might as well go back and check. Might as well. Let's start off with 2. So inside the square root, negative 3 times 2 is plus 10 is 4. Square root of 4 is 2. 4 plus 2 is 6 equal to 2. That's unfortunate. Let's try 3. Negative 3 times 3 plus 10 equals 3. Well, negative 3 times 3 is negative 9. Plus 10 would give us 1, yes? What's the square root of 1? Oh, that's not good. 4 plus 1 is? It's 5 equal to 3. So, not by hand. There's not an easier way than that, solving it by hand, because you could plug it into the calculator to get there.